Hello everyone and welcome to our webinar Building Real-Time ECG Monitoring Applications with .NET MAUI and Syncfusion charts. I am Shriram Sankaran, Senior Product Manager at Syncfusion, and I'm thrilled to share how we can build a cutting-edge ECG monitoring app that updates in real time. So this session is perfect for developers in healthcare, IoT, or any field needing responsive cross-platform data visualizations. So we will leverage .NET MAUI's cross-platform framework and Syncfusion's high-performance SF Cartesian chart to create a scrolling ECG chart that runs smoothly on Windows, Android, iOS, and macOS. So get ready for a hands-on live demo and let's make some code magic happen. First, we will take a quick look at an overview of the live demo to understand what we are building, a real-time ECG monitoring app with Syncfusion's charting tools. Then, the main event, a live demo where we'll build the ECG app from scratch, showing you how to create a scrolling chart with 10 Hz updates using .NET MAUI and Syncfusion's SF Cartesian chart. So we will cover the data model, view model, UI, and code behind, all using the MVVM pattern for clean architecture. Finally, we will wrap up with a recap and key takeaways, plus resources like Syncfusion's documentation and GitHub sample to help you continue exploring. So it's going to be an interactive session, so feel free to ask questions in the chat. Now let's talk about the live demo, the heart of our webinar. Our goal is to build a real-time ECG monitoring app that displays a scrolling chart updating at 10 Hz, mimicking a realistic ECG waveform with PQRST patterns. So the app will run seamlessly on Windows, Android, iOS, and macOS, showcasing .NET MAUI's cross-platform power. So we will use Syncfusion's SF Cartesian chart with Fastline series for high-performance rendering, an observable collection for live data updates, and an iDispatcher timer for 10 Hz refreshes. So in the demo, I'll create a chart model class to store X and Y values for each data point, a real-time chart view model to manage live data and simulate ECG waves, a main page XAML file to design the chart UI with axis and series, and a main page XAML.cs file to start and stop updates. So this will demonstrate a clean MVVM architecture, thread-safe updates, and efficient rendering perfect for medical, IoT, or financial apps. Before we start coding, let's have a look at the prerequisites. For the live demo, we will need Visual Studio 22 with the .NET MAUI workload, which lets us build cross-platform apps for Windows, Android, iOS, and macOS. Then we need the .NET 9 SDK as our project targets this framework for the latest features. We will also use the Syncfusion MAUI Toolkit NuGet package, which includes the SF Cartesian chart for a high-performance chart. With these ready, let's jump into the demo to build our ECG monitoring app. So first, let me open Visual Studio. So here's Visual Studio 22. The project you see on screen is a fresh .NET MAUI app targeting .NET 9. So it's set up with a basic structure, including the MAUI program.cs file where we configure the app. Next, we need to add the Syncfusion .NET MAUI toolkit to use its high-performance charting controls for our ECG visualization. So let's do that now. I will navigate to the NuGet Package Manager. So in Solution Explorer, I'll right-click the project, select Manage NuGet Packages, and search for Syncfusion MAUI Toolkit. So let me do that. So here's the package. So we'll install the latest version. So this gives us access to Syncfusion's charting components like SF Cartesian chart, which we'll use for the live ECG display. So now we need to register the Syncfusion libraries in our app. So for that, what I will do is I'll just open MAUI program.cs file. So this file is the entry point for our MAUI app, where we configure services and dependencies. To use Syncfusion, I will add one line under the builder section. So let me just proceed to add the necessary code. So this line tells MAUI to initialize Syncfusion components, making the charting controls available for our XAML and code behind. It's a simple but crucial step. With Syncfusion set up, we are ready to start building a data model. So let's create a new file called the chartdatamodel.cs to define the structure for our ECG data points. So I'll just proceed to add the new file. So I've added the file to the project. This class will hold the x and y values for each point on our ECG chart. So let's write the code for it now. So value is the x-axis position like a time index for the chart. Size is the y-axis value representing the ECG signal amplitude. And that's our chart data model. It's a simple class to store data points for the chart. Now we'll build the view model to manage these points and make the chart update in real time. So I will create a new file called real-time chart view model to manage a live chart data. So I'll just proceed to add the new file right now. So here's the new file in Visual Studio. The view model will handle the ECG data updates and drive the scrolling chart. So let's add the code step by step and explain what each part does. First, the class definition with iNotify property changed. So I'll just make the necessary changes to the class. Okay. So now the iNotify property changed implementation. So let me add the necessary code related to it. So this defines the event and method to notify the UI when properties change, ensuring a chart updates dynamically. So this is the code that's related to it. Next, I'll proceed to add the fields to store our data and timer. Okay, so these hold our chart data, a random generator for ECG waves, a timer for updates, and an index for points and a limit of 100 points. So now let's proceed to add the constructor to initialize everything. So this sets up the random generator and data collection. Next, the live data property for chart binding. So I'll just proceed to add the necessary code related to it. So this connects our data to the chart and notifies the UI of changes. So now moving on to the methods, I'll just start with the method to simulate ECG values. So I'll just add the necessary code related to it. So this method, what it does is that it creates a fake ECG wave pattern, as you can see on screen. Next, we will proceed to adding the method related to initializing data points. So this one's a chart with 100 starting points. Next, let's add initialize data points. Before that, I'll just fix this. Yeah. So next, let's add initialize data points to the constructor. So I'll just move to the respective code and call initialize data points. Okay, so following this, we will just code the timer stick handler. So I'll just navigate to the necessary section and add the code for it. So this removes all points and adds new ones for scrolling. Then we will just add the necessary code for starting the timer. So this runs updates every 100 milliseconds for real-time data. So following this, we will have stopping the timer related code. So let me just proceed to add it. So this stops updates when not needed. Alright everyone, we have created our chart data model.cs and real-time chart view model.cs to manage the ECG data. Now let's build the UI in mainpage.xaml to display our live chart using Syncfusion's SF Cartesian chart. So what I will do is, I will open mainpage.xaml and add the code step by step explaining what each part does. So let me just navigate to the necessary file. As the first part, we need to add namespaces to use Syncfusion controls and our view model. So at the top of the content page tag, I will add the necessary namespaces right now. So the chart namespace brings in Syncfusion's charting controls like SF Cartesian chart. The local namespace points to our project's namespace so we can use our real-time chart view model. So now let's replace the default content with our chart. So I'll add the binding context right now, followed by which I'll also add a grid. So starting with the binding context. So this sets our real-time chart view model as a data source for the page, so we can bind the chart to its live data property. Next, I'll move to the main layout and add the grid. So I'll just proceed to remove the already available code. So the grid is a layout container. Inside it, the SF Cartesian chart is in Syncfusion's chart control. So I'll just add the necessary code related to it. So this is like set to fill the page with horizontal options and vertical options, which you will see right now. So following this, what I will do is I will add the other related properties related to the chart now. And let's have a look at each section individually. So this section adds a title centered with some padding and a large font for visibility. Next, we'll move to the x-axis section. So the x-axis setup defines the x-axis as a numerical axis for sample indices. So show major grid lines equal to false keeps it clean, and edge labels drawing mode equal to center aligns labels nicely. So the title is samples for the time axis. So the y-axis is also numerical with a range of 500 to 1100 to match our ECG values, no grid lines, and the title's amplitude for signal strength. Finally, we will move to the chart series. So this uses Fastlane series for smooth real-time plotting. Item source binds to live data from a view model. X binding path equal to value maps to the sample index, and Y binding path equal to size maps to the amplitude. And enable anti-aliasing makes the line smooth. So that's it for the XAML. So this sets up a live ECG chart. Next, what we will do is let's add the code behind in mainpage.xaml.cs to make the chart update in real time. So I'll just open the file and add two methods to control our view model's timer. I'll just remove the not needed code first. And I'll add the on appearing method right now. So let me just add. So this runs when the page loads. It calls the base method for default behavior, stops any existing timer to avoid duplicates, and starts the view model's timer to update the ECG chart every 100 milliseconds. So next, the on disappearing method. So I'll just add the necessary code for that. So this runs when the page is hidden. It calls the base method, stops the timer if the view model exists, and disconnects the charts handler to prevent memory leaks. So that's it. These methods start and stop are live chart updates. So let's run the app to see the ECG scrolling in real time. So there you go. Here's a real-time ECG chart on screen, updating at 10 Hz with a smooth scrolling effect. You can see the PQRST wave pattern with peaks and dips generated by a get next ECG value method. The chart maintains 100 data points, adding new ones every 100 milliseconds and removing the oldest, creating the seamless scroll. So the Fastlane series ensures high performance, and you can run this on Windows, Android, iOS, or Mac OS with the same code base thanks to .NET MAUI. So this is exactly the kind of real-time visualization you can use for medical monitoring, IoT dashboards, or financial tracking as we set out to achieve. And with that, we have reached the end of our demo. So what a ride it's been. Let's recap what we have accomplished in this webinar. We built a real-time ECG monitoring app with .NET MAUI and Syncfusion's SF Cartesian chart, achieving smooth 10 Hz updates with a scrolling chart that mimics realistic ECG waveforms. Using the MVVM pattern, we created a chart data model for data points, a real-time chart view model with an observable collection for live updates, and an iDispatcher timer for thread-safe 10 Hz refreshes. So the Fastlane series ensured high performance rendering across Windows, Android, iOS, and macOS, perfect for medical, IoT, or financial apps. So with respect to the key takeaways, .NET MAUI enables cross-platform apps with a single code base. Syncfusion's SF Cartesian chart delivers efficient real-time visualization. MVVM and observable collection simplify live data handling. And thread safety with iDispatcher timer is critical for smooth updates. To explore further, check out the full code on Syncfusion's GitHub, the link for which would be shared along with the YouTube video, or try the 30-day free trial at syncfusion.com. So with that, we have come to the end of this session, and I would like to hand it back to Carter for any final remarks and the Q&A session. Over to you, Carter.